Guys, I'm gonna teach you how to make a ping pong ball float, and it's not using your pinky, but this is very cool. You take a cup, put a hole, put your pinky in there, and you can make it look like it's floating. But we're gonna use some science today, and I'm gonna teach you how 100% to make a ping pong ball float in midair, and nothing but science. On top of that, we're gonna do some awesome experiments with water, and we're gonna learn about something called air pressure. Did you realize that air is all around us, all pushing on us at about 14.7 psi? That's pounds per square inch. When air pressure starts to change, it can look like magic. Things start to move. So we have high air pressure and we have low air pressure. You can think of the high air pressure as kind of the bully. It loves to push. So this pressure all around us, it's pushing on us. Wait a minute, how are we not being crushed by this? Well, our bodies at the same time are pushing out atmospheric pressure. Pushing out atmospheric pressure, canceling each other out. So air pressure close to Earth, molecules are very close together, very dense. And the higher up in the atmosphere you go, those molecules are more separated, less dense, which is why if you're ever on an airplane and your ears feel like they start to pop, it's because the pressure inside your body is greater than the pressure around your body. Even the tiniest air molecules have weight, and collectively they weigh a lot, pressing down on whatever's below. Okay, time to demonstrate this. If you want to play along, you'll need a glass, some sort of postcard or mail, and a bowl to catch the water, or you can use the kitchen sink. With the glass half full, we're going to place the postcard over the glass of water so we trap some air in there. We're going to place our hand on top. We're going to flip over the cardboard and the cup, and then you're going to release the piece of cardboard. And it should float. It's magic! Now, why does this work? So when we flip the card, air pressure, higher air pressure, is pushing up on the card, while inside there's no push happening because there's a vacuum that's formed between the water and the top of the glass. There's air pressure all around the top of the glass, which is pushing down the glass, but it's not pushing down the water because of the vacuum that's formed. Now there is one force that's pushing down, and that's the weight of the water. So why doesn't it push the card off? Well, the weight of the water versus the air pressure pushing up, the air pressure is stronger. What do you think would happen if we drill a hole in the top of the glass? Well, air pressure would be able to get into the glass, push on the water, and the card would not stay in place. So let's take a look at what happened when I used a glass with a hole in it. Let go of the glass. Then the weight of the water. So if the glass has the hole in it, not only is the air pressure pushing down the water, but so is the weight of the water, which is stronger than the air pressure pushing up. So that's a great example of why air pressure can look a lot like magic. The water inside the cup is actually lighter than the air outside. And the difference isn't even close. The amount of pressure pushing up on that card is about 15 pounds, whereas the amount of pressure on the water is at about 1 pound. So the high air pressure underneath was pushing up on the card. Now, think about airplanes.
All right, who's over the Rockford VOR right now? 1143.
Airplanes. What makes an airplane go up into the air? Air pressure. What happens is when high air pressure starts moving so fast, it's like it doesn't have time to push on anything. It's just moving so fast. So the air above an airplane's wing is moving so fast, it doesn't have time to push down, which allows the air underneath the wing to push up, giving the plane what we call lift. We're gonna look at air pressure, use a 2-liter bottle, and maybe be over your sink again. Right, get some parental help right here. I used a drill bit, took my 2-liter bottle, put a tiny hole in the bottom of the bottle. Then I fill up the bottle with water about halfway. I screwed the top back on. What do you think happened? Well, what do you notice is not pouring out of the bottle, out of this tiny hole? There's no water coming out. Why? Just like the other experiments. All around here, we got high air pressure. High air pressure always wants to be where the low pressure is. So it's trying to force its way through that tiny hole, but it can't get to it. But what it is doing is it's preventing the water from leaking out. Now, as I release this cap, that higher air pressure is gonna rush in there to get into the low air pressure and push down on the water. So you can almost create your own little drinking water cooler here. So if I unscrew this, as I unscrew it, how cool is that? Now, as you tighten the bottle again, it stops. So you can set one of these up in the corner of your house, fill it with some ice water, and whenever you're thirsty, you have your own little water fountain. All right, guys, time for a challenge that you can do with a family member. You can get any type of funnel. This is a funnel that I use in my kitchen right here, but you can get a bigger funnel too. It'll work the same way. Pretty much you want something that you can fit the ping pong ball in. You ask somebody in your family if they bet that they can blow the ping pong ball out of the funnel. But something's gonna happen. What do you think's gonna happen when I blow really hard into the bottom of the funnel? Do you think the ball's gonna pop out, or do you think something else? Let's find out. What's happening? Think about what we talked about with low air pressure and high air pressure. I'm a little dizzy right now, so I gotta take a breath. All right, so it's kind of a sneaky challenge because it's impossible, no matter how hard you blow. And actually, the harder you blow, the harder it is to get the ping pong ball out. So what's happening is when you blow with force up through the tunnel, how's the air moving? It's fast. What happens with fast moving air? Doesn't have time to apply force. It's late. It's late for work. So all that air goes around the ball, speeding past the ball. But what about the air pressure up here? High air pressure, just chilling, hanging out, pushing down on the ball. So the high air pressure from above is stronger than the air pressure you're blowing out. Okay, so this kind of tricky, but let's make it look like magic. So if what I said was true, and that the fast air pressure was moving around the ball, but this side of the ball had high air pressure pushing down. Does it matter which way the funnel and the ball are? What if I start blowing really hard and tipped it forward like this? Would the ball fall out if I continued blowing the low air pressure? Okay, here we go. We got the ping pong ball. You got to keep your eye on the ping pong ball, because if you don't keep your eye on it, keep your eye on it. Okay, we got the funnel. We're going to start like this. I'm going to go underneath without touching the ball. Here we go. Now, it worked. It stayed in the funnel. Let's try it one more time. Again, ball's floating in there upside down because the high air pressure is pushing up and the pressure that's coming out of my mouth is lower because it's going fast. Empty water bottle, go grab one right now, and then just get a little piece of paper or a napkin or paper towel and crumble it up so it takes about less than half the space, or even up to half the space of the opening in the water bottle. We're gonna lay this on the table, or you're gonna hold it for somebody. You're gonna place the paper right there. Go get the materials. I'm gonna show you an awesome challenge that looks like magic. Okay, so you're gonna hold the water bottle horizontally, that's side to side. Then you're gonna take your little paper or paper towel, paper, and place it right on the edge, just like this. Now, you're gonna challenge somebody and tell them all they have to do is blow that paper without touching it, blow that paper into the bottle. Will it work? Let's find out. What in the world is happening? This is crazy. So why do you think it's impossible to blow a tiny piece of paper or a tiny paper towel into the bottle? Well, think about everything we've talked about so far. What's inside the bottle already? Air. When you blow into or at the paper can't get into the bottle because it's already filled with air. So when you blow, the air that's in the bottle kind of acts like a barrier, and the paper or paper towel bounces off, has nowhere to go, and that's why it always bounces out of the bottle. So the air that you're blowing into the bottle past the paper is flowing right back out, pushing the paper. So even a tiny little, it's gonna push it out, and a big one is gonna make it go flying, but it's never gonna go inside the bottle.